All right, let's learn another thing about Unit 9. We're going to take a look at percent composition. Basically, if you think of an atom, or excuse me, if you think of a molecule or a compound as a pie chart, okay, so you've got different amounts of that pie chart being taken up by different elements, basically. Okay, so if you think about H2O, you think, oh, there's two hydrogens and one oxygen, so it must be mostly hydrogen. Well, remember on the periodic table, hydrogen is actually really, really tiny, and oxygen is much bigger than hydrogen. Okay, oxygen has a molar mass of 16, and hydrogen has a molar mass of 1.01. So even times 2 is just 2.02, which is still significantly less than 16. Okay, so this percent composition is by mass of the elements. So let's take a look at potassium carbonate. Okay, potassium carbonate is written as K2CO3. So if we're going to find the percent composition, we need to count up our elements. K, C, O. Potassium, I've got 2 of. Carbon, I've got 1 of. And oxygen, I've got 3 of. Okay, so let's find out what the molar mass is. So potassium is 39.10, which would be 78.20. Is that right? Yes. And carbon, of course, is just 12.01. And oxygen, of course, is 16. Okay, so here's what we want to do now. We want to add all this up and find the total molar mass. Okay, so I've got 78.20 plus 12.01 plus 48. And that gives me a total molar mass of 138.21. So what I'm going to do to find the composition is I'm going to divide each of these by the total molar mass, 138.21. 138.21. 138.21. Okay, so I'm going to do 78.2 divided by 138.21, and that gets me 0.566. Let's go one more decimal. 0.5658. 0.5658. 0.5658. Okay, then we get 12.01 divided by 138.21. And that gets us 0.0869. And then I have 48 divided by 138.21. And that's 0.3473. So now what I'm going to do is I am going to multiply each one of these by 100 to get my percentages. Okay, so I know that when you have potassium carbonate, I know that 56.2 or 0.58% is potassium. 8.69% is carbon, and 34.73% is oxygen. That's how we do percent composition problems. Let's take a look at how we can use percent composition to help us out with some different things. So this says how many grams of pure magnesium could be recovered from the decomposition of 49.4 grams of magnesium fluoride. Okay, now the first method is to use dimensional analysis. Okay, you already know how to do dimensional analysis. We've done a ton of it. Okay, I want to show you how you can use percent composition to find out the same thing. So you've got magnesium fluoride, MgF2. We want to use our method to find out. So we got Mg and F. We want to find out the percent composition of each of these. So magnesium, I've got 1 of, and its molar mass is 24.31. And then fluorine, I've got 2 of, and its molar mass is 18.99. So that is 24.31. This one is 1938, 37.98. Let's add those up, find out our total molar mass. So 24.31 plus 37.98 is 62.29. That's my total molar mass. And so we're going to divide both of these by 62.29 so that we can find out our percent composition. So 24.31 divided by 62.29 is 0.3902. 3903 actually. Okay, and 37.98 divided by 62.29 is 0.6097. Okay, so now if I'm going to find the percent composition, which why not? Let's go ahead and figure it out. Multiply these by 100, you get 39.03% magnesium, 60.97% fluorine, okay? But we actually aren't even going to use, we're actually not even going to have to go all that way, because what we can do now is we can take, so we wanted to know how many grams of magnesium, pure magnesium, are there. So what I can do is I can take this value, 0.3903, and multiply it by the mass of the entire compound, okay, or the mass of how much we have. Okay, so 0.3903 times 49.4 equals 0.3903 times 49.4 is 19.3 grams of magnesium. Okay, could you have solved that using dimensional analysis? Yes. However, you can also, if you feel comfortable with this, okay, dimensional analysis is 100% going to work every time. Okay, why? Because dimensional analysis is awesome, and that's how we do things around here. If you feel good about percent composition, however, you can use this method, okay? You got to be careful, not multiply by 100 at the end and all that stuff. You're basically multiplying it by the fraction. But, like I say, if you feel good about that, use it. We're going to practice this like crazy in class, so just get ready to be awesome. All right.